Welcome back, guys. In this video, I'll cover the dev prod parity section of the 12-factor app. To begin with, at a high level, dev prod parity, below the title, if you see it, they're saying keep development, staging, and production as similar as possible. So prod parity is about keeping development, staging, and production as similar as possible. Historically, there have been substantial gaps between development and production. So, as per their experience, I think development and production in the good old days have never been similar. They've always been substantial gaps. So the gaps manifest in three areas. The time gap. A developer may work on the code that takes days, weeks, or even months to go into production. The personal gap. Developers write code, ops engineers deploy it. The tools gap. Developers may be using a stack like Nginx, SQLite, and OS X, while production deploy uses Apache, MySQL, and Linux. So the time gap, there are three main areas where gaps manifest. The first one is time gap. Basically, the developers take a long time to deploy their code. So the code for days on end, and then they deploy it. So that's one problem where the development environment becomes out of sync with what is in production because there is that huge a gap. Personal gap. The developer is writing the code and the ops engineers are deploying it. So there is definitely when people don't communicate properly in these kind of situations, there are problems. And the tools gap. So the developer is using one set of tools, but it's deployed to a different set of tools. So these are the three main problems when it comes to dev prod parity. The time it takes to install, for the personnel who are doing the DevOps, and basically the ops engineer and the developer are not in sync, and the tools gap. The developer uses a different tool set, but we deploy to a different kind of tool set. The 12-factor app is designed for continuous deployment. By keeping the gap between development and production small. Looking at the three gaps described above, so 12-factor apps are designed for continuous deployment by keeping the gap between development and production really small. So you do continuous deployment to make sure, hey, you write code, you test it, and it's ready for deployment. Break up the features into as small a feature as possible. Develop it, test it using continuous integration and continuous deployment, and push it to production. So the difference between dev and production is really small. Looking at the three gaps described above, make the time gap small. A developer may write code and have it deployed hours or even just minutes later. Make the personal gap small. Developers who wrote code are closely involved in deploying it and watching its behavior in production. Making the tools gap small. Keep development and production as similar as possible. So the gist of dev prod parity is 12-factor apps are designed for continuous deployment so that the gap between development and production is as small as possible. And so they give three ways to keep the gap really small. One is making sure the developer writes the code and it gets to be deployed like within hours. And the second way is making sure the developer is as close to deployment as possible. So he understands how it's being deployed. And the tools gap, keeping the developer's local dev environment as close to production as possible. Summarizing the above in a table. So they talk about the three, how these, why dev and prod have huge gaps. In the traditional, it used to take weeks between development and push a build from development to production. In 12-factor app, it's supposed to take hours. Code authors versus code deployers. In the traditional app, there used to be different people. Nowadays, they are the same people. Dev versus production, divergent. So dev and production environments were divergent. Nowadays, they are as similar as possible. Backing services such as apps database, queuing system, or cache in one area where dev prod parity is important. Many languages offer libraries which simplify access to backing service, including adapters to different types of services. Some examples are in the table below. Okay. So one way to minimize the gap is making sure we use a library that will let us connect to a backing service. So that way, even if the backing service itself changes, there is not a lot of code that needs to change. So in this case, the examples given are for database. If we are using Ruby on Rails, then use a library like active record, which will connect to MySQL, Postgres, and SQLite. And if it's a queuing system, and if the language is Python, Django, we can use a library like Celery to connect it to various adapters like RabbitMQ, Beanstalk D, and Redis. And so basically, Active Record can use either a MySQL adapter, Postgres SQL adapter. So it looks like Active, the libraries listed here will be using different adapters to connect to the different data sources for a database. Same thing for queuing, and same thing for cache. So you can use a active support cache. Active support cache library can use any of these adapters to connect to those respective systems. Developers sometimes find great appeal in using a lightweight backing service in their local environments, while a more serious and robust backing service will be used in production. For example, using SQLite locally and PostgreSQL in production, or local process memory for caching in development, and memcached in production. The 12-factor developer resists the urge to use different backing services between development and production, even when adapters theoretically abstract away any differences in backing services. So a 12-factor developer is supposed to resist the urge. I think a 12-factor app is an app where the developer will use the same kind of backing service in development as that is used in production. Differences between backing services mean that tiny incompatibilities crop up, causing code that worked and passed tests in development or staging to fail in production. One of the reasons why developers should not use a different backing service in their local dev environment is there will be some tiny differences, and they could end up causing problems in production, even though they pass tests locally. These types of errors create friction that disincentivizes continuous deployment. The cost of this friction and the subsequent dampening of continuous deployment is extremely high when considered in aggregate over the lifetime of an application. So yeah, so these types of, whenever the developer uses a different backing service, basically the dev environment is not similar to the production environment, then whenever you push something to production, and if the test starts failing, then it disincentivizes the developer to use continuous deployment. They will say that no, they're breaking. They don't want to create a 12-factor app at that point. So they're breaking the contract. Lightweight local services are less compelling than they once were. Modern backing services such as Memcached, Postgres, RabbitMQ are not difficult to install and run thanks to modern packaging systems such as Homebrew and apt-get. So there is no incentive to use a different backing service because there are enough packaging systems that make it easy for you to install a backing service. They give examples like Homebrew and apt-get packaging systems that make it really easy to install backing services on a local developer's desktop. Alternately, declarative provisioning tools such as Chef and Puppet combined with lightweight virtual environments such as Vagrant allow developers to run local environments which closely approximate production environments. So the other two options are, there are declarative provisioning tools like Chef and Puppet that can be combined with lightweight virtual environments like Vagrant, which will allow developer to run local environments that are as really close to the production environment. The cost of installing and using these systems is low compared to the benefit of dev prod parity and continuous development. So the cost of installing is pretty low compared to the benefit of dev prod parity and continuous deployment. Adapters to different backing services are still useful because they make porting to new backing services relatively painless. But so adapters are still useful because in case you want to change the app architecture itself and you want to use a different backing service, the adapter makes it easy. But all deploys of the app should be using the same type and version of each of the backing services. All deploys of the app, developer environment, staging, production should be using the same type and version of each of the backing services. So adapters to different backing services are still useful. Okay. So what they're saying is all deploys either to the local dev environment or to production or staging should use the same backing services. So to summarize dev prod parity, for a 12-factor app to be called a 12-factor app, the dev and the production and staging, all the environments should be very little gaps. So they should be as close as possible. The gaps used to exist because the developers never used to deploy their code. They used to deploy their code after a really long time after they developed it. And the second problem used to be, there used to be a gap between developer and DevOps, and there used to be a gap between the tooling. So the developer used to develop on a set of tools, and then it was used to be deployed to another set of tools. So one way to reduce the gap is developer writes the code and it's deployed like within hours. And the personal gap is reduced. Basically, the developer plays nowadays a dual role, or they're as close to the deployment as possible. And the third way, the tools, and basically you end up using the same kind of tools in development and production. So nowadays, backing services, you connect to a backing service using a set of libraries and adapters. That makes it easy. There is no reason for not keeping your dev and production environments in sync. So the developer, for a 12-factor app, the developer should resist the urge of substituting using a lighter weight backing service. Basically, a bottom line is a 12-factor app should make sure that the dev and prod are in parity, by that they should be as close to the same as possible. And they give a list of ways to reduce the gap between dev and prod by making frequent deployments using continuous deployment. And developers act or are really close to the deployment, and tools are exactly similar, or there are very small differences between the tooling, between dev and production. That's all we have for dev and parity section. In the next section, we will be covering logs. I will stop this video for now.